Hello and welcome to the Engineering Room, a monthly series of long-form conversations with influential people from the software world. The Engineering Room series is sponsored by Equal Experts, and I'd like to thank them for their ongoing support. So if you'd like some help building great software or are interested in finding a great place to work, do check their links in the description below. I first met today's guest when we both started work for a consultancy called ThoughtWorks at roughly the same time. I had an idea for a book at the time on distributed systems and systems integration, but I fairly quickly dropped that idea when I got wind of his project because his was a much better idea. The book was Enterprise Integration Patterns, and my guest, friend and former colleague is Gregor Hohpe. If you haven't come across Gregor before, where have you been? Gregor is a world-class expert on software architecture and the role of the architect. He's a technologist, an expert on the topics of large-scale systems and the cloud, as well as lots of other stuff. He's currently enterprise strategist for AWS. In the past, he was technical director in the office of CTO at Google. And before that, he was chief software architect at Allianz, the German insurance giant. Gregor is an international speaker, author of some great books, as well as writing his always thought-provoking The Architect's Elevator blog. He's thoughtful, full of wisdom and good company. So I'm really looking forward to catching up with him here today. Gregor, welcome.
Yeah, hi, good to reconnect, and hello to everyone from Singapore.
So you are a self-professed architect, and like me, think that architecture is important. Why does it matter?
Yeah, so being an architect is an interesting job, right? He has like three different people. He gets three different definitions of what architecture and being an architect means. And to be quite honest, I don't think I have the answers even. I can only share sort of where my current thinking is at. Right? My current thinking is that architects are kind of the people who see things that not everybody else sees. They like sort of look at things from a different angle. They look at things from slightly different dimensions. And I find that very helpful in the context of software delivery, right? Delivery without architecture probably runs into trouble, but likewise, architecture without software delivery is also not very meaningful. You just get tapestries. But I think sort of having the ability to have the delivery team see one side or one dimension, having the architects looking at the same thing from a different point of view, I think that combination is actually really useful. And to make that more concrete is architects often look at things from the dimension of the rate of change, right? Often when we build software, we look at, okay, what does the software need to do, right? And then we build what it needs to do. But of course, what the software needs to do will change. Also, the scale it needs to support will change. The platform it sits on might change. Any other things might change. So the architects often, I say, they live in the first derivative, right? They don't look just at the static picture. They also look at how things will change over time. And that's one of those additional dimensions. So that's why I think it's very important.
Cool. So that aligns very nicely with some of the things that I've been thinking lately in terms of what counts as good software engineering in a different ways. I've started to use the phrase that I think that the quality of the systems that we build is defined by our ability to change the systems. And so working in ways that allow us to change the systems is essential. I like that perspective in terms of, taking that broader picture of change. Do you see these things though as being very different? Do you see architecture and software development or software engineering, being distinct? I confess I see them as a little bit blurry between where the boundaries are.
Yeah, they're definitely blurry. I think most important, as already hinted, they play off each other. So It can never be that one is more important than the other, or sort of one can be done without the other, right? So I think it's critical to understand there are sort of two sides of the same coin. They're only valuable in combination. So that puts away with all the discussions like which one is more important, which one do I do first and last, right? I never have an answer to those questions because to me it's sort of inherently jointed at the hip. Right? And I think that way it adds value. Now, if we talk about how distinct it is, I find it useful to separate architecture as a function from architecture as a role, right? There's the architecture and then there's the architect. right? And both of those have gradations on how distinct or how healthily blurred they can be, right? Like in many cases, the architect role actually sits within the teams. And many companies don't even have people with the title architect. Like I worked at Google before, there's no architects. I work at AWS now. We don't have folks called architects, but surely we have a pretty decent architecture, so somebody is doing it. And I think once you make that separation, this sort of which side does what kind of thing takes, it takes on a different kind of light, and you have a more fruitful discussion about it.
Yeah, that reminds me. That reminds me of I think I heard from Martin Fowler, which he was talking about a colleague of ours, David Rice, who was grumbling one day about hating architects, and Martin was laughing because David Rice was an architect at ThoughtWorks.
Yeah, the David Rice grumbling maybe wasn't sort of the rarest of occurrences. The biggest challenge with being an architect is that there's so many labels stuck to your role, sometimes very positive and sometimes very critical. At the same time, I'm not a big fan of sort of relabeling exercises. So I'm happy to just be called the architect. And if somebody doesn't like that, I said, well, rather than changing the word, let's redefine what that word should mean. And then we can put a more positive spin on what architecture is all about. But I don't believe in sort of just changing the label and somehow believing that that makes a difference.
Absolutely. And what one of the things that amuses me in a different way is that I think that often you and I talk about, when we in blogs stuff like that, you and I talk about very similar topics, similar ideas, only I'm coming at it labeling it from a software engineering point of view, and you're labeling it from an architecture point of view. And I agree with you. I don't really mind too much what the words are, except there's a degree to which words can kind of do the NLP kind of thing, where they can just help you think differently in sometimes. Anyway, we're kind of wandering off a track a bit. So
yeah, I get what you mean.
Yeah. So the idea of architects, I would agree 100%, and I liked your take on separating the idea of architecture from the idea of architects. It's not the province of some people in an ivory tower somewhere. It's a practical thing. One of the things that seems to me to be, let me ask this as a question rather than as a statement. So do you think that the role of somebody doing architecture needs to include technical ability to be able to touch the system at all levels of technical complexity? Should they still be programming?
My answer is yes, but not to deliver code. So, and I have a great example myself of an experience I have. So I work for a cloud provider, right? I figure like, I should try our own products, right? Like product company and not using a product, I find to be a little bit of a silly proposition. So I'm like, all right, I should go build something. So like almost a year ago, I said like, all right, let me build some serverless stuff. You mentioned enterprise integration patterns. So I took some of the examples from that book from 2003, Bobby Wolf and I wrote this and said, hey, what would these things look like if I build them on serverless? I don't share my eyes wide open, like totally cool stuff, everything there, automation, auto scaling, all the kind of cool things. But what I brought back with me from this exercise was also some very different ideas on what serverless architecture means, application topology, the role of automation. So I came back, basically the code I wrote, I could almost throw away. It's like sort of toy code. It was like, demo code. But the reason the architects should dive into what I call the engine room and get hands-on is because they come back with a whole different set of ideas, right? They start understanding some of the constraints, some of the trade-offs, some of the relationships, and then looping those back to the teams, that has the value. So you should code as an architect, but not to actually deliver lines of code, but to understand the ramifications of the decisions you're making, because otherwise you do drift to the ivory tower, right? If this is one way and you never go and look sort of what happens, then that's the slippery slope to the ivory tower. So I'm a big fan of going down into the engine room.
Yeah, and this is your idea of the architect elevator, which is the way that you what you call your blog site. It's that idea of kind of bridging from the engine room to the boardroom kind of thing. That picture.
100% right. And this is another facet in which the role of the architect has changed very much, right? It used to be sort of like the architects make all the difficult to reverse decisions. I'm like, well, how can the architects be so smart that they can make all those decisions facing change, we already mentioned, and facing uncertainty? I'm like, wow, you must be at least smarter than I am as an architect. So the role has very much changed from making all the decisions, or let me put it another way. The role has really changed from trying to be the smartest person to making everybody else a little bit smarter, right? That's what I see as the role of an architect. Let the people who are better qualified to make the decisions, let them make the decision, but give them a different mental model or different ways to think about it, or highlight some trade-offs, make them smarter so they can make a better decision. And a key element in this is connecting across the layers, right? Organizations just have a lot of layers. There's the business strategy, the financials, the products, the product strategy, and somewhere down here, somebody is writing Helm charts or CDK code, right? And the question is, how does one contribute to the other? And normally there's like 15 lines of management in between separating the two. And I always say, this is one case where loose coupling is not good, right? Because you don't want to be decoupled between your business and your technology. So architects connecting across the layers, riding the elevator, that is a key aspect of how modern architects bring value in the organization.
I like that too. It's not surprising that I think I'm going to be agreeing with you quite a lot during the nature of this conversation. But one of the things that brings to mind. So the way that you're talking about that enabling a team through architects and architecture. I speak about that in terms of technical leadership. So it's the role of technical leadership to do that. And the mental model that I have in the back of my mind for thinking that is the idea of a sports team. The coach of a sports team doesn't have to be the best player, but they've got a different perspective, and they're looking at it from this different perspective that you're talking about. And their job is to try and get the best out of the players that are on the field. And it's a loose analogy, but it's one that's sort of stuck in my head. Is that the kind of thing that you're talking about? So you're talking about strategy, tactics, and individual help to people in particular problems.
Absolutely. We already talked about sort of software delivery and architecture having sort of a healthy fuzziness. So I would say technical leadership and architecture has that even more so, right? So in the end, the only thing I would highlight, there's sort of two very different aspects on it. The technical leadership also includes people leadership, right? You make sure people have a purpose, they are motivated, know where they're going. And that's important for both architects and technical leaders. But there's also the content aspect, right?
Yes.
Like, what uncertainty do we need to deal with? Sort of what is the next business idea our business is likely to have, so we can maybe anticipate some of that, that change, that first derivative we talked about. So there's both the people leadership as well as the technical leadership, which really connects across the different layers. And doing both well, I think are signatures of both a great technical leader and a great architect. If anything, sort of maybe one person is sort of 70-30 and the other person is maybe 30-70. There might be sort of a slightly different emphasis, but I come back again to my argument, one without the other is completely meaningless, right? So it's just like, you need to have both, and you can have a sweet spot in one or the other, but you got to stand on both legs. Otherwise it's going to get a little tiring to balance.
So does this exploration start to get us to a point where we can start to say what architecture is?
Well, I always say when you use the word architecture, three different people might give you three different answers. And the irony is they could all be right. So we first need to see which architecture we're talking about, right? There's the architecture in the system. Like as soon as you have like two parts, they have an architecture, right? They're either connected or disconnected, or one is on top of the other, next to each other. You cannot compose something without an architecture, right? So that's always there. Then there's architecture, which I think you refer to, like the act of choosing the structure, right? Like doing architecture. And then the third architecture is like, oh, let's talk to architecture, like the team, the function. So if we talk about the middle ground, right? To me, the key aspect of doing architecture in a way as being an architect or being somebody else doing architecture is, I come back to my things, right? Look at your system for more dimensions, for more aspects as you normally might, right? And design the system that it can cope with those external forces. And change and evolution is the primary one, as you already said. Kent has a lot of thoughts on that. And the reason architecture is getting also a boost recently, so let's remember, right? There was sort of a time when people thought we don't need much architecture, right? It was sort of you write in JavaScript, or no, this is like lucky go happy, right? We don't need architecture. And on top of that, there was sort of the notion that the big frameworks do your architecture, right? Like the J2EE kind of thing, like, oh, that's your architecture. It already comes from the vendor. So you just need to put a few lines of code here and there, right? There was a time when architecture had sort of a little winter. And in the last couple of years, we see a huge resurgence of it. And I think that has a couple of reasons. The one is rate of change is up, right? You can no longer build something and let it run for like 5 years, right? It's like a million things will change. Uncertainty is up because there's two kinds of change, right? There's change that you know, and there's change that you don't know. So they're like two slightly different dimensions of dealing with change. Like what's the rate of change and what's the level of uncertainty? Basically, sort of where am I going and sort of how fuzzy is that spot on the map where I'm going. So that is certainly going up, absolutely no denying. And the kind of applications that we're building are becoming better, but also more complex. I mean, let's be honest, sticking a big monolith on a single VM is just simpler than building a distributed auto-scaling, auto-healing application. It doesn't do all the stuff that you would want. It doesn't scale, it's brittle, it doesn't do the change. So there's good reasons we're doing it. But we got to be honest also, our runtime architectures are more complex. So to me, these are all reasons why the need for this little extra magic sauce of architecture, why that need has gone up. And I hope I sort of cleverly skirted you answering your question precisely. But as I said in the beginning, it's all thinking in progress, right?
I know it's a complicated it's a complicated thing to define, which is one of the reasons why I think it's interesting, because it's seen. I think that you and I would both agree that it's extremely important to be able to deliver good, effective software, to be thinking in these terms of broader structures, longer time horizons or different time horizons, as you say, a variety of different perspectives, scalability, resilience, all of those sorts of things. But
you need to balance those, right?
You've got to balance that. And it's also difficult to. I think one of the things that seems unusual to me in the people that, from my perspective, are good at this kind of thing is that ability to be able to jump levels, mentally, from the detail. I always used to think, when I was acting in the role of architect for projects and stuff like that, that as you said, my job wasn't primarily to be writing production code, but I should be able to sit with somebody writing production code and at least understand what's going on and understand what it is that they're doing and what the code means, and that sort of thing, and maybe do as you say, examples to demonstrate concepts, those sorts of things. And then you've got this range of different ideas. So you've got to be able to do that jump of, contextualizing the big picture architecture stuff in terms of lines of code, because they have an impact on one another.
Absolutely. And I think your example is spot on. In the end, it's, if you build any complex system, and I really mean system, not just in a technical sense, but also the organizational structures, right, of software delivery, like, the social technical system. We have fancy terms for this now, right? There's always, it's a balancing act, right? You put a certain mechanism in place, and that mechanism serves you, but it leaves other gaps. right? And then you put sort of the second layer, the second order mechanism on top to kind of make that downside as smooth as little as possible. And the layers is a classic example. Layering serves us extremely well because we all joke about the full stack developer and the 10x developer, right? It's like at the end of the day, specialization is important, right? You need to be able, not everybody can do everything. If I was writing, the text code for the company, we'll probably all be in jail for a long time, right? It's like somebody else, the CFO does that, right? They do the filings, right? They do this fantastically well. I do something different. So specialization, especially as the complexity in the world we live in goes up, right? You gotta have some scope, otherwise you just go bananas. But we exactly know the downside, right? If you layer different layers, people will optimize their layer because that's what they know, that's what they can control. And let's be honest, usually that's what they're rewarded for, right? And that works well, but it has a flip side, and I call the flip side that the sum of local optima is rarely or never a global optimum, right? So you have a second order problem. And then the architects are great people to address that second order problem. It's like, okay, I don't want to do away with all the layers because, hey, like my whole structure is built like this. It's very difficult to do. It's like in a high riser, you can't just take a few floors out, right? That won't work. So what can I do as a second order mechanism? Well, I can have more mobility of some people through these layers, right? They make sure that the one local optimization doesn't sort of harm the other local optimization, and that you keep the end-to-end view in mind. And I think that captures quite well what architects do. We're sort of like a second order mechanism over the other mechanisms.
Is it one of the ideas that I've used from a practical point of view in kind of working in that kind of architecture role, I suppose, is the idea of architecture as kind of like a tourist map. So the system architecture. So the idea is to have kind of a high level. It doesn't need to be detailed, accurate, so that you can kind of, measure run lines on a chart or anything like that. But it's the kind of tourist map that you have if you take your kids to the zoo, and there's a picture of the gorillas over here and the giraffes over here, and there's a topologically correct but non-geographically accurate link between the pieces, so you can just find your way around and you can have conversations, and that kind of that's one of the tools that I think about using, of kind of trying to cut across those lines so that everybody can understand the tourist map.
Yeah, and this is why I have to agree with you a lot. Unsurprisingly, I've written a blog post about thinking like an architect, and the first part of that is that architects sketch. We're not the people who make the blueprints, and that has happened in the past, and I didn't find it very useful. And I'll give you a couple of reasons why. Like, when you look at sort of traditional enterprise architects, those are the people with the tapestries, right? The giant posters where all the systems and everything is depicted. And they look impressive, but they're not particularly valuable. And the reason they're not that valuable is because they don't have a good abstraction. They're trying to document reality, but good architecture emphasizes the abstraction. You're not trying to map reality, you're trying to map what's important to you. Like, how many meters or feet for our other colleagues, right? The gorilla case is, and exactly how many 100 yards from there it is to the giraffes or something is completely irrelevant, right? And the giraffes can be like this big and the gorillas can be the same size. It doesn't matter, right? In this context. So you have a point of view that determines what's important and what's less important. And that's interpretation. That's not sort of given in some schematic. That depends on what question you're looking to answer, right? I say, if you don't have a question, you don't need a picture, right? And if you have a question, you should have a picture that helps you answer that question. And that will drive what's important in this map and what's not important. And that's why the zoo map looks a bit cartoony. And in fact, the gorillas might be the same size as the giraffe, which is totally wrong. But it gives you the exact information that you need, because let's say next you go to see the squirrels, they wouldn't even be visible on the map. Makes no sense, right? So you make things in a way, you pick abstractions that answer the question, which is like, well, which animal should I go to see? And that's why architects sketch. We make things that are more a little bit like cartoons, more like comics almost, if you wish. We're not there to make the blueprints, because the blueprints, they lack that emphasis, they lack that interpretation.
So that seems to get to interesting territory to me. So
yes.
particularly
the zoo.
But particularly given your recent roles working for cloud providers. So the question that I want to get to is, are there off-the-shelf architectures? Because to a degree, there are patterns that we, certainly cloud providers, but previously you could say that, one of the most successful, approaches to software development over decades was kind of the layered system of RDBMS backed software, because it solved some fairly important nasty problems in a relatively straightforward to understand and use way. Do you think so clearly there are canned architectures to some degree. What's the role of those, and where are they useful and where are they not, would you say?
Very, very interesting question. And I'll sort of negate a little bit that I said earlier that you picked on, where certainly I don't believe in sort of renaming things, because in this context, naming is very important, right? And this is what I think you hinted at earlier, right? Is names do matter. So yes, there are higher level constructs. So it's very interesting to build a cloud platform, because on one hand, platforms are pretty magical, right? And I'm writing a book on platform strategy. Some of my readers will know it's slow going because it's a very complex topic, but platforms are sort of this magic thing where you harmonize a layer. I always say AWS is a single product company, right? It has like 200 whatever services, but it's one AWS. That's basically like one thing we sell. But on top of it, you can do pretty much whatever you want, right? And finding the balance between making high level enough services so that you can value, because you could say, oh, I can also build anything I want on the JDK, and you'd be right, but it's a different starting point, right? Like starting on the cloud is a whole other level, right? You have fully running functional services available. So the platform captures this magic of standardizing certain elements so that you get value from it, but not presupposing all the problems that you're going to solve. Right? And that's sort of the magic trick of building a platform. I often say, if nobody does anything that you didn't anticipate, you didn't build a platform. Triple negative. Let me spin this around, right? If you build a platform, somebody needs to do something that you did not anticipate. If you anticipate everything, you're making a shared services library or some other stuff, that's good, right? But that is not a platform. The platform is a thing that you can do more with than the people had originally perhaps assumed.
If I can just interject, that gets back to this idea of thinking in terms of levels of abstraction. We're abstracting services, whatever else, in a way that gives people more freedom to use them in a variety of different contexts.
Very, very nice way of putting it, right? So in the past, people have always thought that if you harmonize something, if you standardize something, you take choice away, right? When I joined Allianz, I was originally the head of enterprise architecture. To be honest, I had no idea what that really was. And then one of the things that I was supposed to do was maintain the standards. And then I soon found out that the person who maintains the standards is easily the most hated person in the IT department. Well, right next to the security folks, right? Because you're basically telling people all the things that you cannot do, right? It's sort of the verboten list, right? Oh, you can have this database, but you cannot have that database. So the notion is always, if you standardize something, like, people will feel constrained, they can't do anything. Now, platforms and cloud platforms are highly standardized. As I said, we're not going to build another AWS just for you, right? That's not how the business model works, but you can do pretty much whatever you could dream of. So that's the baseline, that understanding the dynamics of a platform. Now comes the really great question, is like, is there sort of one layer of the services you build, and is there another layer of architectures that you make from these services, right? Is there sort of a hard layer, if you wish, right? Like hard layer, I mean, it has an API, it's a running services, it will send you a bill, right? It has security access control, like it's a running component. So that's like a hard layer. But is there sort of a soft layer on top, like patterns? Sometimes they call it atoms, or what does Neil Ford always call it? The sort of unit of architecture. If we both don't know, It's really embarrassing.
I can't remember.
You have to look it up. Sorry, Neil. Apologies. We'll reread Strata? No, I don't know. Everybody, and the reason probably I don't remember the term is because everybody is looking for, okay, if the cloud gives you the atoms, here's like event bridge step functions, SKS, SNS, your lambda, whatever, all that stuff. Those are your atoms. What are the molecules?
Yeah.
Right? I think that's what we're all after, right? And I think my experience so far has been doing this bottom up is very difficult because only the chemists, or in different countries, chemists do different things. The people who do chemistry, right, the chemical science people, be careful, only they call things by the ingredients, right? Like only the chemistry folks would say H2O. The rest of us all say water. This is the stuff you pour in a glass and you drink, right? So you have a very different point of view of why the molecule is useful. Like, I don't need hydrogen and oxygen. I need the liquid thing called water. And it so happens to be made out of 2 hydrogens and 1 oxygen. So doing this from the bottom, the chemistry people see like, what are you guys talking about? It's H2O, right? So the idea that you have a whole different view on this is actually not easy. And making a long loop back to my vocabulary, so that's why we need a vocabulary like water. We cannot call the next level things up H2O, right? That's not going to help the people that much. And so the disclosure here, we started doing that, and I'm critical of it, right? We started making some components. They're called lambda, SQS lambda. And I'm like, that's convenient, but it's not an abstraction. Like, it can't be an abstraction because it's labeled by the pieces. So if you don't understand the pieces, you have no idea what lambda, SQS lambda would be, right? So you need a vocabulary for this thing. You need a different language. You cannot make an abstraction that requires the user to go down into the atoms and then sort of come back up, right? It's like, that's kind of a detour. You need something where something that's closer to the way people think, right? And water, right? In the chemical example, maybe in this example, maybe it's competing consumers, right? And
I have an example. I have an example that's kind of closer to home, at least for me, which is I think of that as the difference between DevOps and continuous delivery. So the terms. So DevOps is the the bottom up atoms, and continuous delivery is the goal that we're trying to achieve.
Yes, I agree. And that's where the key thing, in order to get any architectures for the cloud, right, you need to have that vocabulary. Because otherwise people, and this is difficult as an industry, like it's sort of it's like sort of a pendulum exercise, or I'm famous for car metaphors. It's more like the shock absorber exercise. What we tend to do as an industry is go from here to there, and then we sort of slowly dampen out. And you know exactly what happens with these architectures, right? On one hand, the vendors usually like, what do you want? There's 200 services, right? They're all fantastic, and they are, but what else do you want? And then we tend to go to the other extreme and say, here's the ultimate blueprint that solves all your problems. And I'm like, I don't know about that one, right? So the middle part is much harder to do. And I think we both agree the middle part has to come either from the top, or it has to come from the customer need. I say it has to come from the back, like it has to, from the objective, going backwards. And that's the only way to find the useful vocabulary. A continuous delivery expresses what you're after, and DevOps might be a way to get there, but it really impacts the way you think about it.
And that seems deeply important. One of the things that was going through my head as you were describing that, and I've come to realize I do this quite a lot, is use operating systems as an example. So operating systems have been around for a long time. They've evolved over a long time and changed significantly, but they are crucially an important level of abstraction in our systems. They provide those top-down views. We have notions of applications and files and those sorts of ideas, windows,
networks,
whatever they might
sockets, and stacks, and file systems, and we had decades to find those abstractions.
Yes, and it took a very long time, and it strikes me that the cloud is currently going through that exercise of trying to figure out the pieces. We had the pieces a long time before we had this assembly and put them together into abstractions that made sense in operating systems. I started at a time where printer drivers didn't really exist. So every time you wrote some code to print anything out, you wrote the code for your printer. So figuring out where those useful customer user outcome centered viewpoint comes in, and working to that seems crucial to me to be able to get to those things. And I'm pleased that you said that, because I think that's an important. I think it's a bit of a gap in my perception of the cloud services so far, trying to find that sweet spot between, defining that user perspective that gives me a working model but doesn't constrain me too much, versus just having a toolbox full of pieces.
Yeah, two comments on that. The first one is, one of my first intern projects was writing a printer driver for Hewlett Packard. When the first time you could software control your printers, hot items. So that's why we always have a great time chatting, because we share many similar battle scars. So the remote control front panel, I know very much what it was called. I wrote the prototype for that. So, but we leave that fun for the finding the vocabulary. It's an interesting exercise, right? Because being a vendor, it puts you both in the best spot and in the worst spot to do that, which is really interesting. But it puts you in the best spot because you have all the customers, you see what the customers do on your platform, you talk to them all the time, right? So you're in the perfect spot, you get all this kind of input. So this is great, right? You should see these patterns. But at the same time, you're also in a tough spot because all your thinking, your organizational structures, your revenue, everything is based on the building blocks you made, right? So it's very hard for you to get to that higher level vocabulary, because like, oh, which team should be doing this? Is it event bridge, step functions, lambda, SKSL? It's like, well, right? And you're already on the wrong track, right? It doesn't fit that structure. So I'm living this right now, and it's really interesting. How can I get a new kind of language, a new kind of thinking into something that's inherently built from the bottom up, because we got to build the platform from the bottom up. So how do we get the signals and translate them into finding a meaningful language without immediately falling back into the service names? I actually spoke at reInvented, some Gartner event about this, and it was about switching costs, like every vendor's favorite unfavorite topic, like lock-in and switching costs and stuff like that. And I said, one of the things that can happen to you is, if you start thinking only in the service names of one cloud provider, right, whichever one it might be, if you only think in the service names, you've already become mentally locked in. And it's nobody like actively locking in, it just sort of happened to you, right? So you're going to put on your tinfoil hat a tiny bit and be able to express your architecture in a different way, right? Find a vocabulary that is your vocabulary to express the architecture, not the catalog of services, right? That's coming right from the vendor, right? And in simple cases, I managed to do this, and you realize sort of serverless is my favorite territory, so I always come back to things like Event Bridge, right? You can build a message translator, you can build a recipient list, you can build a message filter, right? Those are the vocabulary you should use. But what I haven't quite cracked yet is 20 years later, there should be more patterns than Bobby and I documented last 20 years ago. So it must be richer than that. And that's what I'm sort of trying to chisel away at. Like, are there whole other language pattern families that allow us to express the cloud architectures in a way that they don't depend on the service names or the service slicing, let's say? That would be magical.
And deeply important to get that kind of vocabulary of patterns to be able to express ideas in a general case. I had a conversation with somebody, it's probably a year or two ago now, but we were talking about some specific problems that they were having in this organization, and I was talking about some design approaches, and this person kept translating it into the language of Kubernetes all of the time, and I was busy trying not to, and he was busy trying to pull it in that other direction, and I think it's it's a common trap to fall into, because when you're building stuff, you're obviously close to the tools that you're working on. But I think it's important to be able to take that step back to really understand what's going on. So I would really, I'm delighted that you said that, because that, I think that's a really important point to pull out of. It's one of the things that always annoyed me about for years. Microsoft would always kind of take the language and kind of completely turn it on its head and have a different set of language than was in general use in everywhere else. And it was a conscious embrace and extend.
Yeah, if you're happy to drink the Kool-Aid, you might be good, right? If you like, if the Kool-Aid is tasty, right? But I bring this back to our point at the very beginning. That's the difference, because you're an architect, whatever level, sort of abstractly, like, because you're an architect, and the other person is a Kubernetes engineer, right? And the fact that you can see the thing sort of one level removed, like basically you can go up and come back down, right? It's not about floating in space, right? But you can say that thing is maybe a network virtualization. He will say, or she will say, ingress, right? It's like, that's the incarnation of it. But what we're after is have some sort of network virtualization, which we could also do with a different naming system, right? For example, right? So it gives you the lifting things one level up. Lets you see things that you otherwise might not see. I come back to my original statement, but it broadens the solution space, right? Because it brings things back to the problem space. Like, what are we really after? And once you know that, the choice of solutions suddenly totally broadens, versus if you only talk in the vocabulary of a specific product, your solution is sort of going ahead of the problem. Right? We see this a lot, actually. And this is probably architects' biggest frustration, where people is like, oh, I already have the solution. I'm not sure what the question was, right? And architects are the ones, we are the ones who are like, all right, everybody, calm down. Let's take a step back here. And my biggest pet peeve is some people come and say, oh, this is too academic. This is that's the hot button you don't want to push with Gregor, right? It's like, oh, it's too academic. I'm like, whoa. Why is it bad to be academic? Because most of us went to school and got to where we are by learning things in university. So that wasn't all bad. And B, it's like, let's use our brain a little bit. Like, let's think and abstract a little bit, as long as we come back down. That is a very valuable exercise. So I tend to push hard, very hard. I tend to push back on these, oh, it's too academic. It's like, no, thinking is allowed here, people, right? Let's lift it up, but land back down somewhere. But where you land might be different than where you started, because you have a much broader view. And that's a classic architect maneuver.
Yeah, absolutely. One of the reasons it seems to me that this is important, I'm quoting you back at yourself from something that I read that you wrote, which is that there's been a change in the industry, which is something that I've also thought for a long time. There's been a change in what it is that we do with software. Is that initially, in the early days, largely we were just automating processes that were already in place. Now we're creating new things, and the quote that I read from you was basically something along the lines of, digital's not the same as changing the model. Digital just means digital stuff, but changing the model is kind of where modern software is. We are now at the level where the information tools that we have are helping us to approach new ideas and deal with different kinds of problems that we hadn't thought about before, and in new ways. And we're kind of in a separate, the next stage, I suppose, of the information revolution in that sense.
Yeah, and this is sort of taking the architect elevator a few floors up, right, or near the top floor, right? What is actually the role of IT, right? And some people again would say like, oh, that's like a very academic exercise. Like, no. If anything that you build isn't connected to what the role of IT in your organization is, like, it's a failure, no matter how great your technology implementation is. So that connection is vitally important. And you're absolutely right. In the past, IT grew big by automating things that the business was doing anyway. Right? You mentioned I worked at Allianz, right? So the traditional insurance IT, and insurance was actually a very early embracer of like mainframes and heavy-duty computing. But what they do is like risk calculations, Monte Carlo simulations, payments, renewals, claims, right? They would do all the things an insurance company would have done 100 years ago, right? And with great returns. They made them all faster, accurate, more efficient, cheaper, right? Repeatable. Like it was always better than before because now it was digital, you said the keyword, but it was basically what I call a digital copy. You took something the business was doing by hand and you made the same thing digital. And, to be fair, that served us well for about half a century of IT, right? This is sort of from the 70s, late 60s, 70s, until not that long ago, until sort of the internet and the cloud and all the other exciting stuff came about. And now the technology is no longer replacing stuff we did by hand. Now the technology allows us to do things we never even dreamt of, like something that's not even conceivable without the tech stack. And in the top floors of the elevator, that shift is so difficult because all the processes, everything is geared towards, oh, I have this existing thing, I'm going to make it digital so that way it's better, cheaper, faster. Huh? Now it's just like, I don't even know what I'm going to be doing. And everybody's like, whoa, 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 how can I fund the project that doesn't know what it's going to deliver? It runs up against all existing processes. And that's sort of my day job, right? When I'm not dabbling with patterns and serverless, my day job is working with executives, helping them through that mental change. Big shift for organizations.
Yeah, a huge shift. And one of the things that I stole from you a few years ago, we were both talking at a conference in Singapore, and I saw you do a presentation where you were talking about this, kind of idea of sort of the architect elevator and so on. But one of the things that I really loved, and I've taken and I've attributed it to you, but I quote it all the time, is the idea of you can understand the organization's approach to IT based on the reporting lines of the IT function. I love that, and it goes from kind of very traditional things where if you're reporting to the CFO, you just kind of a cost center and you need to be kind of eliminated largely to a partner in the business where economies of speed are what matter. And I loved that model in terms of being able to I thought it was deeply insightful. There's lots of information in that chart that you publish.
But it comes back to many of the aspects we just addressed. The one thing is you got to ride the elevator, right? If you don't know what's going on up there, you cannot make decisions in the engine room, right? Because you don't know what's likely to change. You don't know how success is measured, right? How you're going to make technical decisions. So you gotta look up there. So that's the first dimension. The second dimension of this is technical architecture, organizational architecture also intertwined, right? The reporting line matters for the technology decisions, right? And you're absolutely right. The traditional model is IT reports to the CFO. And I always give people these examples. So like saying, if you go and tell your CIO that now I can deploy 100 times a day, right? And they talk to their boss, right? They're not going to be interested because if it's a CFO and is measured by cost, speed to them doesn't matter. And then what happens to technical folks, they say like, oh, they don't understand. I'm like, well, they're pretty smart people. They didn't get there sort of randomly, right? So I don't think they don't understand. It might be like they don't care or they don't see the benefit, right? So you cannot sell somebody who only cares about cost. You cannot sell them speed, right? So you need to like two things. A, translate this into a cost benefit, like the cost of delay, right? If I can deliver something in a month versus 6 months, hey, those 5 months I'm generating benefit. That is money in the bank. If I can reduce software inventory, that is money in the bank because any line of code that's not deployed is cost that delivers no benefit. That's inventory. No CFO likes inventory, right? It's like the stuff that piles up that nobody bought, that's rotting probably, right? So if you make this translation, then you can get sponsorship from those folks, but you can also get input into making much better decisions. And finally, that's again the elevator, right? But on the top floor of the elevator, understanding reporting lines really tells you a lot about how the organization is wired. So I also still use that chart quite a lot. It's one of my blog posts on the architect elevator. You could find it there. I think it's called Reverse Engineering IT.
We'll put a link in the description to that blog post. I think that kind of winds back to the thing that I mentioned earlier, which is the way that I've started thinking about the definition of quality in modern systems is our ability to change it, because you know, you know, my engineering shtick at the moment, where, you know, I'm trying to promote the idea of software development as an engineering discipline, applying scientific style thinking to solving problems. It seems to me that starting out knowing that we don't know all the answers yet is really important. Assuming that, you know, whatever answers we've got are probably wrong and may change, and maintaining our ability to evolve our thinking and our understanding is how we get to these more complicated systems that we've been talking about so far today.
Yeah, and you mentioned two very important words there, right? It's like the uncertainty, the change, and also the complexity. So I have some quite some thoughts on this one. The first one is, both of us come, you mentioned at the beginning, right? We come out of sort of the, I don't want to say the birthplace, but probably sort of one of the early places where Agile, you know, hit the mainstream, right?
Yeah.
And Agile development is very much born out of this insight, right? If I know all the answers and nothing ever changes, I don't need to be Agile. Just write it down, I build it, you know, I'm done.
Yeah.
Right. Now, that's not the context in which software is being delivered today. So hence, we are very fond of Agile methods. And what cracks me up is that sometimes people come and say, oh, I don't need architecture. Say, oh, you're an architect, that's very nice, but I don't need you because I'm Agile. I'm like, oh, that's quite interesting, because if you're Agile, it means you deal with change and uncertainty. Like, oh, yeah, lots of change, lots of uncertainty. I'm like, perfect. So does architecture, right? Because if you don't have change and you don't have uncertainty, you don't need architecture either. So first big insight is really agility and architecture go hand in hand to deal with a world that has high rates of change and high levels of uncertainty. They go together. They're not opposites at all. I often say, Agile is the steering wheel, architecture is the engine, right? One keeps you moving, and the other one makes sure you move in the right direction. So that's a common misconception. The other word you said, though, is the complexity. And we said, you know, good architecture is making systems ready for change, yes? And this is absolutely true, but there's always a secondary effect, right? And usually the secondary effect is a negative one. So if you make a system ready for change, it's easy to increase the complexity, right?
Yes.
So that if you want everything to be changeable, either you reinvent the JVM, you know, no need to do that, right? You can do anything you want, but you didn't deliver much value, right? So no need to do that. Or you drown in complexity, right? And this is where in our industry, it's sort of a status, like a bragging right to have a law. So I felt compelled to also have my own law. So I call it Gregor's law. And that is that excessive complexity is nature's punishment for organizations who are unable to make decisions. So the game is that, yes, you want to defer some decisions, right? You want that ability to change, but that deferring has a price, and that price is largely complexity. So, and as architects, we find ourselves right in that middle, like basically, which things can I lock down that bring my complexity down, but that afford me future ability to change. And simple examples, right? So let's say people writing software, and we don't know what languages they're going to want to use, right? Or they can agree, or it's going to change in the future. You're like, okay, I make a services architecture and I make common APIs, right? So if you have common APIs, right, the next service can be written in whatever language. Quite honestly, though, well, two main thoughts on this. On one hand, it's one of those classic maneuvers where taking some choice away gives you more choice, right? Like I forced you to make common APIs, and I forced you to use, you know, JSON and OAuth and HTTPS, right? I lock many things down, you know, being sort of the old enterprise architect here, right? I standardize some things, but it doesn't take your choice away. It actually increases your choice, because now you can mix and match. You can deploy in the cloud. You can run here. You can run there. Different languages, right? So first thing is, it's a classic maneuver of making some decisions enables others, but also, to be fair, I increase complexity a little bit, right? Now you need an API layer. You have partial failures, retries, idempotency, out of sequence messages. You have things like, oh, in JSON, the field is missing. Is that the same as null? Is that the same as empty string? Is that right? All the little fun stuff we deal with all the time, those complexities, we just all injected into our system. So a couple of thoughts to this. On one hand, you know, and as I said earlier, I have a hard time with having a definition for architect, and the reason is I have many definitions. So one of the definitions for architects is we are option traders, right? Basically, what choices do I take away because I gotta take some choices away. Otherwise, I drown in complexity, Gregor's law. So which choices do I take away? But what choices do I gain in return, right? That's sort of the classic role of the architect. And the other way of putting this is, so we are sort of the flexibility versus complexity balancers, right? It's like, how much ability to change can we have, and how can I do this without complexity, running or spinning out of control? That's another key role that architects do.
Yeah, absolutely. And again, we are kind of in 100% agreement and talk about it in slightly different ways, but it's interesting. So my one of my foundational ideas in terms of software engineering principles is the idea of managing complexity. So making those choices that allow us, give us those freedoms, but as you say, they incur more work. So I have some examples in my book where it talks some little code examples, and I point out that if we're going to go for more modularity, better separation of concerns, and so on, there's probably end up with a little bit more code. But it makes the system as a whole more flexible, and you can deal with it in different ways. And I'm talking about the trade-offs between those, those different ideas. I'm certainly in my head, as you were describing that, that's what I was translating it into. I think we're talking about the same idea there. This trade-off between those three. I think that's an insight it took me a while to get to, but you've stated it really nicely, which is that idea of the constraints are a tool that we use to give us those freedoms in other areas. So there are parts that matter more it seems to me there are parts that matter more in the design of software than other parts. I don't, the idea of something like modules or APIs, the boundaries between them, are more important places in the code than the internal detail of the implementation. The internal detail clearly has to work, but you should be able to change it in a whole variety of ways. Those more important places need a different kind of thinking, more architectural thinking, I suppose.
Yeah, absolutely, right. So just two comments, right? The one thing is, because it sounds a bit abstract, but it's like really important, right? This is at the essence of architecture, but it runs the risk of sort of being labeled as academic again. So that's why I like sort of real life metaphors. Now I worked in financial services, so that's why the options theory, right? Like options trading, right? Sort of, what's the strike price? What's the price of the option, right? I use that a lot with my customers because that's stuff they know from the industry domain. So if you can do that as an architect, make that translation, it really helps get your concepts across, because it's not so easy to put it in the right words. And the second part of it is, of course, I'll bring this back to the architect elevator. So let's say you're faced exactly with one of those decisions, right? I can make this more modular, so that affords me a bit more changeability, but I pay some complexity. Like which way is better? You, as a technical person, you cannot answer that unless you understand the business and the business strategy and the variability up there. Like you cannot make a good decision about this without understanding the levels above you. And I have a fantastic example, right? Insurance business, we once wrote a sort of tablet, really cool stuff, digital, where people can buy insurance, right? And it was really successful. You put your coverage in, and then it tells you how much your premium would be. 2 months later, or shortly after, great success, the business comes like, oh, we want to do this in the inverse, right? Because Southeast Asia, people have limited budgets. So people want to put in how much premium they're willing to pay. And you're supposed to tell me what coverage you can get. And people are like, oh, it wasn't built that way, right? And I went to the business folks and it's like, well, did you assume that this was like the most obvious next thing? And they're like, of course, totally, right? It's like either do it that way or that way. It's like same thing, right? Of course, right? But that hadn't made it to the technical folks. Of course, in the end, we like cheated our way out with like some iterating and dissection interpolation, right? You could sort of, right? We like sort of, put some screws on the front side, right? And the end made it work. But this was a classic example where the business says, of course, that's the next thing we're gonna do. But the engineering team, and they made a really cool calculation engine, right? It wasn't like they just hammered it together. They really put software engineering effort in, but without knowing what the variability points are. So they chose a very elegant architecture that's solving the wrong problem. And that is without knowing what's going up here, you cannot make a good technical decision down here, because you'd be guessing, and you'd be guessing wrong many times.
So what sorts of things? How do you work to keep your options open? What sorts of things are you looking for to figure out how to try and hit that sweet spot of being able to, have the big picture of where we might be going, and the reality of we've got to get stuff out soon and into the hands of people and working.
So I have a relatively simple mental model, and it's somewhere in my blog. I'm disorganized enough that I make everything I write public, so that I can use Google search to find it. Works pretty well. So somewhere I have a mental model where I try to bucket my uncertainty into 3 big buckets. The one is I can guess the answer with high enough likelihood. I just go do it. Yeah. The second one is I don't know what the answer is going to be, but I can boil it down to sort of A, B, C, or D, right? I can make something that sort of has distinct buckets. And then there's sort of the third layer where I have no idea, and I call this there. I just minimize the cost of being wrong. And then I look at sort of what percentage of my problems roughly fall into which bucket, and sort of how can I optimize these kind of buckets, right? The middle bucket, that is clearly, well, the top one is easy if you're right? Yeah. The biggest danger is believing too many things in the top bucket where you thought you're right, but you're not. The next layer down, that's the options, right? Yeah. And to drill into how you deal with that is I come back to the financial services, right? Like when you buy an option, I like really quickly, like options are basically you acquire the right to buy a share of stock in the future. Right? You say like, let's just stick with Allianz, right? I buy an option to buy Allianz stock for 200 euros in 1 year. And the benefit of that is in 1 year, if the stock is more than 200, I can use my option. I buy it for 200. I have money in the bank. If it's less than 200, right, then I don't need to buy it, right? I let the option lapse. So I deferred my decision, right? Very important for architects. I deferred my decision, but I kept my options open, right? I locked in my $200. Now that thing has a cost, right? That option doesn't come for free. Well, there's people making billions of dollars trading these options, right? So the option costs, and it costs us in IT as well. So there's a very interesting metaphor here for the architects, and that is option price versus strike price. And let me pick my favorite topic, cloud migration, right? Multi-cloud, lock-in, that whole story, right? A lot of people try to make the strike price 0. So let's say one day the scenario comes where I need to go from cloud A to cloud B. They sort of dreaming up a scenario where like, oh, I just push a button and it goes from here to here, right? This is what I call strike price 0. When I use the option, it costs me nothing. Yeah. What happens, that option has an enormous price right now, right? Because that's the most expensive option to buy right now. And if you ask anybody from the financial services, there are no options of strike price 0. Like it makes no sense, right? So the key thing to manage the middle layer is sort of how much am I willing to pay now versus how much am I willing to pay in the future when I actually need this option. So let's say, right? I have maybe a 2% chance that I want to switch cloud platforms in 5 years, right? That costs me $1 million, let's say. Let's make it expensive, right? But if that's $1 million, that's 2% chance, it's like 20,000, right? So your liability is like 20,000. Well, how much are you going to build for $20,000? Well, probably not all that much, right? Like, be careful about it. And how about if I try to bring this down from $1 million to like $1,000? Well, that might cost me 200,000 right now. I'm like, oh, that's like 10x, right, for liability. So I highly encourage architects to sort of have this way of thinking, strike price versus option price, and not always believe that the options should be free. They don't have to be free. They just have to be a reasonable balance between the effort I make now and having the option later. Like putting a common APIs between your services, right? The cost isn't super high, and it buys you not a 0 strike price later, right? If I go and build a new service in Golang, I probably have to put some libraries in, do some testing, right? I have some costs, but it's reasonable. So it's about finding that kind of kind of trade-off, right? So that's the middle layer of options. Find the balance between option price you pay now and strike price you might pay when you need to make a change. I wanted to say
no, go ahead.
Yeah, the bottom layer, and I know it's like I'm going down my
Yeah.
mental model pyramid. The bottom layer, right, where I said you have no idea, you can't even define distinct options, right? How do you reduce the cost of being wrong? And I think this one is exactly down your alley. The best way of reducing the cost of being wrong is to increase your velocity. If I can make change faster, if I move more quickly, I have high levels of automation, I have continuous delivery, being wrong is half as horrible, right? Because you just make it right and you never look back. So the bottom layer, the tooling and approaches, right? Thanks to you and many others, right? The tooling and approaches that allow us to deal with being wrong more easily actually allow us to push more things into the bottom layer of that pyramid without paying a huge penalty. So we don't know, big deal, right? We figured out, and when we figured out, it's going to take us 3 days, and so be it. I don't need to buy any options for this at all. I just do it when I get there. It always sounds like a cop-out kind of architecture, but I think the exercise has got to be let that layer live. That layer is there for a reason, and you just deal with it when you get there. If you have high velocity, no big deal.
Yeah. And that enabling, I think the thing that enables is the ability to treat your work and your ideas as more like experiments. You can try out those things and see what works and what doesn't, and that gives you that ability to navigate uncertain territory more effectively.
Right. If you need to change it, no harm done, right? So I think in the end, the biggest progress we made in the industry is that our tooling and our approaches really allow us to reduce the cost of being wrong, right? I run in the cloud, I provision 2 VMs. Oh, I was wrong because I need 10. Oh, BFD, right? I just add 8 and now I'm right. It's just so, I have a change in requirement. Oh, I need to make a change. I've automated tests. I redeploy, right? Big deal. So in the end, acknowledging that uncertainty and just say hey, I make some decisions so I don't drown in complexity. Gregor's law, I'm willing to make some decisions, but I also reduce the cost of making a wrong decision. I think that is one of the most fundamental shifts or the most fundamental ways in which we made progress. But what's interesting about it, so many organizational processes and structures are designed around the old model that it's, this as much as I do, that is really hard to get people into the new model, because go into some sort of traditional IT organization and say, oh, we'll figure this out when we get there. They're like, oh, you're a bad person. You're also a bad architect and you're a bad software engineer. Right? It's just right? So it takes a lot. It is a fundamental change to, rather than always trying to be right and being a good guesser, to just reduce the cost of being wrong. And like you said, let's make experiments. And if it fails, then we'll just do the next one. It's a bigger shift than most people believe, but it's the most powerful one.
I'd agree with that entirely. I think it's probably the biggest challenge that agile style thinking and working faces, really, is that it's such a different way of thinking about problems. And in many ways, I think all of us think that thinking hard and really planning and really understanding the problem is the more professional way to do it. That's kind of wired into our heads a little bit, but I've come to dismiss that. I don't think anything complicated works like that. It's nearly always more like the kind of process that we've been describing of navigating the problem space and finding solutions in that problem space, and giving ourselves the freedom to be able to navigate it. And that to me, deeply scientific idea of starting out assuming that your ideas might be wrong rather than starting out assuming that they might be right is probably one of the most profound ideas in human history in many ways, but certainly it's one of the principles on which the whole of agile thinking, to me, seems to be built.
Yeah, and this happens quite repeatedly, right? When somebody has a transformative technology or something that allows you to work differently, the initial move that people always make, they do what we call substitution. They put the new technology to do the same thing that the old technology did. A colleague of mine, Philip Brunright, he always uses the electric motor, right? In the days of the steam engine, right? There used to be a giant steam engine and all these pulleys and belts in the factories, right? They always like chop people's arms off, right? Kind of thing. And then the electric motor came. What is the first thing people do? Well, they replace that steam engine with a giant electric motor.
Yeah.
I'm like, oh, and the danger, or let's say the tricky part is, it is in fact much better, right? It has more torque, it's more reliable, right? You know, people, oh, this is great, it's so much better than before. But the reality is, you ain't seen nothing yet, right?
Yeah.
The whole idea is you can make the electric motor smaller and make hand power tools. You get rid of all this static machines and all this wiring and belts and pulley and all the dangerous, stupid, stuff, and you have hand power tools, right? And that is sort of the next stage. And that jump is huge, right? The jump from stage A1, because it's so easy to be lulled into stage 1. They're like, oh, that electric motor is fantastic. And not seeing that that is actually a small step. And the big step is available, but only if you fundamentally rethink your assumptions, like having the power in the tool that you use, right? That is a different world. But we see this repeatedly. And I think we are right in the middle of this as the software industry, sort of allowing ourselves to be a little bit philosophical again here, right? Where we shifted some of the fundamentals, right? Like, the cost of being wrong, the changeability of systems, right? We shifted all that. And now we're in this giant digestion process to really understand what that means. And we struggle. We clearly struggle.
Yes. Yeah, absolutely. And one of the things that I thought for a long time is that part of the pleasure, the fascination of doing what we all do for a living, is that it is hard. I don't mind that doing this stuff is complicated. That's why it's interesting. That's why it's fascinating, it seems to me. But treating it as a naive kind of, there's one architecture and you just write the code here and everything will be okay. That doesn't work either. It is creative, and it requires smart people working in smart ways, doing smart things to be able to do a great job.
Yeah, but boredom has never been a problem in our profession, so I'm with you there, right? Like the rate at which stuff comes along, right? That is only going up. And what I enjoy most of it is, like, as an architect, right? We talked about in the beginning about abstractions, understanding trade-offs. The most amazing thing is that understanding those trade-offs really helps people make better decisions. Like, as I said, architects are the ones who make everybody else smarter. But the really fun part is, every once in a while, stuff comes along that basically sort of pulls the rug out from underneath us as architects. Right? And that's really like, whoa, like all these great sort of metaphors I had and all the heuristics that I used, they suddenly don't hold anymore. And I need to sort of reshuffle and reboot. And to me, that is actually one of the most fun maneuvers. But I do know for some folks, that's also a very painful maneuver, right? Because you settle in a space where you know what you're doing, you have good heuristics, right? You do this, you don't do that. And then suddenly somebody comes and turns your world upside down, and you're like, oh, does this make my value go away, right? I mean, it's a serious concern, like, oh, am I outdated now? So I think that's where, sort of coming back to the second order function, that's where you got to embrace sort of the rug that's being pulled from you and say, you just repeat that maneuver, like the way you got to those heuristics, right? You learn those over time, trial and error, going in the engine room, writing code, talking to people, failing sometimes, right? You just repeat that process, right? You just got to do that again. And I think for you and I, that is a big part of the fun. But I can also see to some people that's tiring, right? So I can see both sides of the coin.
Yeah, I know the analogy that was going through my head as you were describing that was, it's not really an analogy. I think it's the same thing. Is in science, there's a the purest view of science is that at the point at which somebody comes along and proves that Einstein was wrong, that's a fantastic moment, because now there's an opportunity to do new physics, to learn new things. Now we know exactly where our ideas are wrong, and we know, we've got a direction. But it's also decent, if your grant was to be studying something about general relativity and it's just been proved wrong, that's going to make you nervous, because we're human beings.
But the people, I mean, if we look sort of back, the famous people in physics, they were mostly people who showed that everybody else was wrong, whether it's Copernicus with the sun in the center, right? The only challenge is some of them were close to be burned at the stake, right? So it's a risky lifestyle, right?
Well,
Or
absolutely.
another thing. But the people who made history largely were the ones who said, like, people, you got it all wrong, right? It's completely different mental model. Right. And the funny thing is, the world never changed, right? Not that much, at least. So it's the mental models that we use. And, this is one of the pictures that I steal, vice versa. So it's a fair trade, right? The one with having the model where the Earth is in the center and it's like the planets move in like some totally ridiculous way. And then you put the sun in the center, like, oh, this makes total sense, right? So the reality hasn't changed, but your model hasn't changed. And linking this back to what we said about architecture, seeing more dimensions, part of the exercise is applying different models to what you see, and you might find a model where things just make a ton more sense. And that's what the famous physics folks like Newton, etc., have done. They found that they didn't change the reality that was already there, but they changed the way we think about it, and they're like famous 300 years later, right? So that has enormous value. Now, I think not every software architect needs to come up with some Newtonian worldview, right? But applying new mental models, like new ways of thinking to existing problems, I think has a much bigger impact than many people assume, and that's what makes it fun to be an architect.
Yeah, and as you say, it's those moments that really move us on, because it gives us new ways of thinking about things. And if we're always thinking about things in the same old ways, then we're bound to be more static. So even if the new ways of thinking about things are wrong, they're new and they're going to give us different kinds of insights. It's an interesting perspective.
Yeah, there's a clever quote on this where it's like, trying to solve new problems with the old way of thinking is insanity, or something like that. Right? There's a clever quote, but something else came up in my head, like short episode. We started at the beginning asking about whether architects should code. I think in this context, one of the other really, really useful things that architects can do is debug, or help people debug. Because debugging is basically the exercise in being told you're wrong, right? That's what debugging is, right? You thought you're right, but the system tells you you're wrong, right? And now the question is, well, where were you wrong? And the end of debugging, sort of the big euphoria, is when you know where you were wrong. So debugging is the place where being wrong is great, because once you find out where you were wrong, you're done with this exercise. So I love sitting down with people, helping them debug. A, it has less risk of me putting bad code in production. B, I help them, right? Really a lot. And C, I take a lot away from it, because I sort of understand where the corner cases in the systems are. So maybe more than coding, architects should also debug, and they should love being wrong.
I like that a lot. I hadn't thought about it that way, but that's absolutely true of the way that I've done things. One of the things that I certainly did when I was playing those kinds of roles in larger teams is I wanted to be in the midst of any kind of production incidents where I could. For the same reason. You want to see where the system's going wrong, because those are the learning points.
And you want to be told where you were wrong, and that's the way you learn, and that's the way you get the system back up and running. So I have really fun stories where folks were trying to do funny things like end-to-end encryption in browser with web workers and multiple threads, and the thing wasn't scaling. And I didn't know JavaScript that well. I only knew web workers from the days when there was like Google Gears, like some decade ago, right? So I basically didn't know very much, but we made a great team. Because it was a little bit like you and the Kubernetes person, like the person I was working with, like knew all the incarnations, all the tech, but I could sort of bring it one level up and sort of divide and conquer. In the end, we made a classic team, and we figured out, of course, the bottleneck was in some sort of library somewhere, right? Like 20 levels down, where somebody had written the mother of all regular expressions, and that thing was just basically using up all the cycles, and nothing was scaling, right? So really fun architecture exercise. So yes, architects should debug is the key statement here.
Looking at the time, I think that we should probably finish on that. I think that's an important idea, and let's just wrap up. So first of all, I'd like to say thank you, Gregor, because that was so much fun. I enjoyed that a great deal. Thank you very much for coming and talking to us today.
And to our listeners, right? Always like these things aren't scripted. Like we didn't know we're going to talk about serverless patterns and cloud abstractions and zoos and maps and high level things, right? So I always love doing those, right? Because in these kind of conversations, you can sort of validate and combine some of the mental models that we have. And to me, that is great fun. And probably our listeners also realize there's a lot going on in both our heads. So I always invite people, architectelevator.com is where sort of most my stuff ends up. So I always invite people to track along there and check out the content and the books. It gives you some idea how my head works, at least a rough one.
Yeah, and we'll put links in the description below for that stuff too. I was at the elevator. Gregor's done his own pitch. I was about to do the pitch for him, but I really strongly recommend the architecture elevator. And actually, Gregor's one of those people that I look for just new insights on things all of the time. I think he's a very creative thinker, and just go and check out his stuff because it's fantastic. I'm going to wrap up now. Again, thanks to Gregor, thanks to Equal Experts for sponsoring. If you've enjoyed the content today, please do subscribe if you're not already, and click the like button. Thank you very much indeed for watching. Bye-bye.
Bye-bye, everyone.